Hey, Talpinger likes math and history, and we're gonna be finding the different ways to represent a function. So, in the previous video, we were explaining what the vertical line test was, and we were also explaining the introduction in a function in the video before that. And while we were using a ratio table in the first video, that is not the only way that you can represent a function. In fact, there's actually 5 ways to represent a function. Let's review how to represent a function with a ratio table. So, just like the first video, we understood that our x is called our input, or the domain. Y is going to be our result of what we put in for x. That is going to become our output, or our range. Here's an example how we can use a table fast. So we have y equals 2x. Insert a number in for x, then when you solve that, you'll get an answer as for y. So let's insert 1 in for x. Y is going to equal 2 multiplied by 1. So pretty much 2 multiplied by 1 is going to be 2. So y is going to equal 2. Y is the result of what we put in for x. So that is the ratio table example, and there are 4 other ways that we can represent a function. Another example that looks like a ratio table is called mappings, and it involves circles that look like these. We have 2 circles, one that represents our x, or input, and the other one is y, which is our output. Mappings is sort of like a modified ratio table, but instead of having a table, we're gonna draw arrows. So, we're gonna put 7, -7, 0, and 3 in, and 1 and 2. So pretty much, this -7, 0, and 3 is going to be called your domain, or what you input. So we write that as -7, 0, 3. You can understand that these numbers are inserted in for your input. Now comes your output. That is called your range. And that is going to be 1, 2. Or pretty much anything that comes out as your result. When you see arrows that point like in this direction, or arrows that come like this, that is telling you that if you put in -7 in for x, the arrow is telling you what you will get for y, which is 2, if you put that -7 in. And if you put that 0 in for x, that arrow is directly telling you to get to 2. And 3 in for 1. So mappings is sort of like a ratio table, but it's another way of thinking that. Just follow the arrow from the x input and see what you get for your output, for y. So mappings is another great way to represent a relationship, or a function. The next thing that we're going to look at is called ordered pairs. And ordered pairs is pretty much almost the same way how we understand the domain and the range for mappings and the ratio table. So with ordered pairs, it's pretty much the same thing. We have a domain and a range. So ordered pairs is just like having the plots on a graph, which we will talk about later. When you see plots on a graph, there's always going to be an x and a y. x and y and x and y. And what these mean is that not only that 6 is inserted for x to get y for 10, but this can actually be plotted on a graph. 6, 10. So if we insert -3 into x, then you will get 5 as y. Your domain is going to be all the x's that you find in this ordered pair. So we have 6, -3, and 6 again. Those are your domains because those represent what you insert for x. Y is pretty much the same thing. We have 10, 5, and 9. So those are our ranges, or what number we get when we insert x into the formula. Since ordered pairs were about graphs, and we were talking about graphs recently, let's move on to the graph. So, using a graph and finding the range and the domains are going to be a bit different than just writing numbers with commas inside them. So, we have two different graphs. One with dots that are plotted on it, and two, we have something that looks like a line with a shaded dot and an empty dot. So let's get started with the ones with dots on them that are plotted. So, remember, the range is what you get for the y, and the domain is what you insert for x. So, in order to do that, we would just plot normally like we did in the previous example for ordered pairs. We have the commas in between the numbers for each of the plots, like we have -2, +1. So we're going to say -2, comma, 0, +2, comma, 1, -1. So we put 1 here, comma, and last but not least, 3, 0, 3. That is going to be our domain, what we inserted for x, because all these numbers, -2, 0, 1, and 3, are actually on the x-axis going this way and that way, left and right. Our range is going to be pretty much the same thing, but we're looking at the second number on the plots. With the range, we're going to put +1, comma, 2, comma, -1, comma, and 0. Because the second number right after your first one is going to become your y's, or what you get as your output. So with a graph, using a ratio table, an ordered pair, or a map is actually going to help you plot the points on a graph and visualize what the plots or the line is. Understanding with a line is actually going to be a bit different because the line is included and we have 2 points. And when we answer for the range and the domain, we are not going to see commas everywhere. We're going to see an inequality because since we're trying to find the x and the y, when we insert the x and get for y, the line is telling you that all the numbers that you get insert for x and insert for y is going to be on this line. For example, the points that we're going to show you are going to be in orange. And these points are all going to work because they follow the purple line going from 0, -3 to 8, -3. So this can explain any number going from here all the way to here, as long as following the line can be counted for. But the problem is, if you guess how many numbers between 1 and 0 are, then if you just say 1, or if you say 2 as in 0.5, that's actually incorrect. There's an infinite amount of numbers. Because you can get 0.99 repeating, 99999, and you can go more and more and more. So there's an infinite number between 0 and 1. That can also explain there's an infinite number of numbers between 0, -3 and 8, -3. So that's why we're going to graph with an inequality. So let's start with the domain. The domain is what we get for the x's. So we have 0 and 8. And we're going to use an inequality. So what we're going to be doing is writing 0 is going to be, since this is a shaded dot in, we're going to be using is less than or equal to x, because x is originally the domain, and we're saying that x can be more or equal to 0. X is this line that is following the orange dots. And we arrive at 8, but it's an empty dot. So we're gonna say has to be less than 8, because since that's open, 8 is not included. Same thing by going to find the range, but instead of x, we use y for the range. -3 is going to be greater, actually less than y, but it's also going to be less than -3. That's what we can use to find the range for this. So, when you're using a graph to find a relationship or a function, it's not necessarily going to be the same as finding the domains and the functions and the range with the ordered pairs and the other ones, such as the ratio table. You might use an inequality to find whatever this is. The last thing that we're going to be reviewing is called an equation. When you are learning about functions, or when your teacher is teaching you about functions, the most common way she will teach you is by using an equation to help you visualize and understand what you insert for x will come out for y. If we insert 3 into x, what do we get as our answer? So y is going to equal 3 multiplied by 2 plus 7. So 2 times 3 is going to be 6, plus 7 is going to become an unlucky number 13. That's what we will come out for y. Or if we insert 5 in for x. When we insert 5 into x, y is going to equal 2 multiplied by 5 plus 7. 2 times 5 is 10 plus 7. Y is going to equal 17. So, when we use an equation, it can quickly help us learn what we insert for x will give us to y. So, we have now learned all the different ways to represent a function or a relationship. Which one of these do you think works best for you? Or which one of these do you like the best or helps you understand what a function is? Type in the comments below. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. And remember, you don't always have to use one way. You can actually combine 2 ways. Like you can use a table to graph on a graph. Or you can use an ordered pair to graph on a graph, or vice versa. You can use a graph to understand an equation as y equals mx plus b. Like and subscribe.